In order to efficiently deliver the most up-to-date information to your stakeholders, you must first understand and optimize query performance within your pipelines. And that's what we're going to explore in the next few videos. We'll discover how to increase throughput and minimize the competition for resources within the system to enable the largest possible workload to be processed. We'll get into database systems, including data marts, data lakes, data warehouses, and ELT processes. That's not a typo. ELT is different from ETL. It stands for extract, load, and transform. You'll also witness how these systems contribute to the overall efficiency of your data systems. In addition, you'll investigate the 5 factors of database performance: workload, throughput, resources, optimization, and contention. And you'll gain some tips for making sure your database intake and storage are the best they can be. Finally, we'll begin thinking about how to design efficient queries that really get the most out of your systems. Let's do it. One of the amazing things about BI is that the tools and processes are constantly evolving, which means BI professionals always have new opportunities to build and improve current systems. So, let's learn about some other interesting data storage and processing patterns you might encounter as a BI professional. Throughout these courses, we've learned about database systems that make use of data warehouses for their storage needs. As a refresher, a data warehouse is a specific type of database that consolidates data from multiple source systems for data consistency, accuracy, and efficient access. Basically, a data warehouse is a huge collection of data from all of a company's systems. Data warehouses were really common when companies used a single machine to store and compute their relational databases. However, with the rise of cloud technologies and explosion of data volume, new patterns for data storage and computation emerged. One of these tools is a data mart. As you may recall, a data mart is a subject-oriented database that can be a subset of a larger data warehouse. In BI, subject-oriented describes something that is associated with specific areas or departments of a business, such as finance, sales, or marketing. As you're learning, BI projects commonly focus on answering various questions for different teams. So a data mart is a convenient way to access the relevant data that needs to be pulled for a particular project. Now, let's check out data lakes. A data lake is a database system that stores large amounts of raw data in its original format until it's needed. This makes the data easily accessible because it doesn't require a lot of processing. Like a data warehouse, a data lake combines many different sources. But data warehouses are hierarchical, with files and folders to organize the data, whereas data lakes are flat. And while data has been tagged, so it is identifiable, it's not organized. It's fluid, which is why it's called a data lake. Data lakes don't require the data to be transformed before storage, so they are useful if your BI system is ingesting a lot of different data types. But, of course, this data eventually needs to get organized and transformed. One way to integrate data lakes into a data system is through ELT. Previously, we learned about the ETL process, where data is extracted from the source into the pipeline, transformed while it is being transported, and then loaded into its destination. ELT takes the same steps, but reorganizes them so that the pipeline extracts, loads, and then transforms the data. Basically, ELT is a type of data pipeline that enables data to be gathered from different sources, usually data lakes, then loaded into a unified destination system and transformed into a useful format. ELT enables BI professionals to ingest so many different kinds of data into a storage system as soon as that data is available, and they only have to transform the data they need. ELT also reduces storage costs and enables businesses to scale storage and computation resources independently. As technology advances, the processes and tools available also advance. And that's great. Some of the most successful BI professionals do well because they are curious, lifelong learners. We've been investigating database optimization and why it's important to make sure that users are able to get what they need from the system as efficiently as possible. Successful optimization can be measured by the database performance. Database performance is a measure of the workload that can be processed by a database, as well as associated costs. In this video, we're going to consider the factors that influence database performance: workload, throughput, resources, optimization, and contention. First, we'll start with workload. In BI, workload refers to the combination of transactions, queries, analysis, and system commands being processed by the database system at any given time. It's common for a database's workload to fluctuate drastically from day to day, depending on what jobs are being processed and how many users are interacting with the database. The good news is that you can often predict these fluctuations. For instance, there might be a higher workload at the end of the month when reports are being processed, or the workload might be really light right before a holiday. Next, we have throughput. Throughput is the overall capability of the database's hardware and software to process requests. Throughput is made up of the input and output speed, the central processor unit speed, how well the machine can run parallel processes, the database management system, and the operating system and system software. Basically, throughput describes the workload size that the system can handle. Okay, let's get into resources. In BI, resources are the hardware and software tools available for use in a database system. This includes the disk space and memory. Resources are a big part of a database system's ability to process requests and handle data. And they can also fluctuate, especially if the hardware or other dedicated resources are shared with additional databases, software applications, or services. Also, cloud-based systems are particularly prone to fluctuation, so it's useful to remember that external factors can affect performance. Now we come to optimization. Optimization involves maximizing the speed and efficiency with which data is retrieved in order to ensure high levels of database performance. This is one of the most important factors that BI professionals return to again and again, so coming up soon, we're going to talk about it in more detail. Finally, the last factor of database performance is contention. Contention occurs when two or more components attempt to use a single resource in a conflicting way. This can really slow things down. For instance, if there are multiple processes trying to update the same piece of data, those processes are in contention. As contention increases, the throughput of the database decreases. So limiting contention as much as possible will help ensure the database is performing at its best. And there you have 5 factors of database performance: workload, throughput, resources, optimization, and contention. Coming up, we're going to check out an example of these factors in action so you can understand more about how each contributes to database performance. Recently, we've been learning a lot about database performance. As a refresher, this is a measure of the workload that can be processed by the database, as well as associated costs. We also explored optimization, which is one of the most important factors of database performance. You'll recall that optimization involves maximizing the speed and efficiency with which data is retrieved in order to ensure high levels of database performance. In this video, we're going to focus on optimization and how BI professionals optimize databases by examining resource use and identifying better data sources and structures. Again, the goal is to enable the system to process the largest possible workload at the most reasonable cost. So this requires speedy response time, which is how long it takes for a database to respond to a user request. Here's an example. Imagine you're a BI professional receiving emails from people on your team who say that it's taking longer than usual for them to pull the data they need from the database. At first, this seems like a pretty minor inconvenience. But a slow database can be disruptive and cost your team a lot of time. If they have to stop and wait whenever they need to pull data or perform a calculation, it really affects their work. There are a few reasons that users might be encountering this issue. Maybe the queries aren't fully optimized, or the database isn't properly indexed or partitioned. Perhaps the data is fragmented, or there isn't enough memory or CPU. Let's examine each of these. First, if the queries users are writing to interact with the database are inefficient, it can actually slow down your database resources. To avoid this, the first step is to simply revisit the queries to ensure they're as efficient as possible. The next step is to consider the query plan. In a relational database system that uses SQL, a query plan is a description of the steps the database system takes in order to execute a query. As you've learned, a query tells the system what to do, but not necessarily how to do it. So the query plan is the how. If queries are running slowly, checking the query plan to find out if there are steps causing more draw than necessary can be helpful. This is another iterative process. After checking the query plan, you might rewrite the query or create new tables and then check the query plan again. Okay, now let's consider indexing. An index is an organizational tag used to quickly locate data within a database system. If the tables within a database haven't been fully indexed, it can take the database longer to locate resources. In cloud-based systems working with big data, you might have data partitions instead of indexes. Data partitioning is the process of dividing a database into distinct, logical parts in order to improve query processing and increase manageability. The distribution of data within the system is extremely important, so ensuring that data has been partitioned appropriately and consistently is part of optimization too. The next issue is fragmented data. Fragmented data occurs when data is broken up into many pieces that are not stored together, often as a result of using the data frequently or creating, deleting, or modifying files. For example, if you are accessing the same data often and versions of it are being saved in your cache, those versions are actually causing fragmentation in your system. Finally, if your database is having trouble keeping up with your organization's demands, it might mean there isn't enough memory available to process everyone's requests. Making sure your database has the capacity to handle everything you ask of it is critical. Consider our example again. You received some emails from the team stating that it was taking longer than usual to access data from the database. After learning about the slowdown from your team, you were able to assess the situation and make some fixes. Addressing the issues allowed you to ensure the database was working as efficiently as possible for your team. Problem solved. But database optimization is an ongoing process, and you'll need to continue to monitor performance to keep everything running smoothly. Earlier, we learned about the 5 factors of database performance: workload, throughput, resources, optimization, and contention. But how do they actually operate within a working system? Let's explore a database and witness how the 5 factors affect its performance. Before we get into how the 5 factors influence this database, let's understand how it's been designed. In this example, we'll be checking out a movie theater chain system. There are a few things that we'll need to consider during optimization. First, let's think about what this database is being used for. In this case, the movie theater chain uses data related to ticket purchases, revenue, and audience preferences in order to make decisions about what movies to play and potential promotions. Second, we'll consider where the data is coming from. In this example, it's being pushed from multiple sources into an OLAP system where analysis takes place. Also, the database uses data from individual theaters' OLTP systems in order to explore trends in ticket sales for different movie times and genres. The OLTP systems that manage transaction data use a Snowflake database model. At the center, there is a fact table capturing the most important information about the tickets, such as whether or not a specific seat has been reserved, the reservation type, the screening ID, the employee ID of whoever entered the reservation, and the seat number. In order to capture details about these facts, the model also includes several dimension tables connected to the fact table, with information on employee, movie, screening, auditorium, seat, and reservation. This database is fairly straightforward, and it enables each movie theater to record data in these different tables and prevents them from accidentally booking the same seat twice. However, these individual OLTP systems aren't designed for analysis, which is why the data needs to be pulled into the destination OLAP system. There, it can be accessed and explored by users in order to gain insights and make business decisions. Okay, now that we know a little more about our database, let's find out how the 5 factors of database performance influence it. First, as you know, workload is a combination of transactions, queries, data warehousing analysis, and system commands being processed by the database system at any given time. In this case, most of the workload is processing user requests, such as generating scheduled reports or fulfilling queries. If the database can't handle the workload, it might cause the system to crash, disrupting users' ability to access and use the data. Maybe a report requires a lot of resources to generate, or there might be a growing number of analysts accessing this data. But we know that it's often possible to predict peak workload times, so we can make adjustments to ensure the system can handle these requests. Now, let's explore throughput. Again, this is the overall capability of the database's hardware and software to process requests. Because our movie theater system is mostly focused on analysis of data from OLTP databases, we're working with an OLAP database that primarily uses cloud storage. The database storage processes and the computers within the system that are accessing the cloud data need to be capable of handling the theater's workload, especially when the database system is being used a lot. The hardware and software that compose the system's throughput are the resources. For example, the movie theaters might use a cache controller disk to help the database manage the storage and retrieval of data from the memory systems. Next, we have optimization, which you've already learned a lot about. Ideally, users should be able to access transaction data that has been ingested from multiple other database systems. If retrieval slows down, it can take longer to get the data and provide insights to stakeholders. This is why keeping the database optimized, even after it has been set up, is important. The last factor of database performance is contention. The movie theater company has a team with many different analysts accessing and using this data. That's in addition to the automated transformations being applied to the data and the reports being generated. All these requests can end up competing with each other and cause contention. And this can potentially be problematic if the system processes multiple requests at the same time, essentially making the same updates over and over. To limit this, the database processes queries in the order the requests are made. And now you've gotten a chance to explore how the 5 factors of database performance might affect a real database system. No matter how simple or complex, these are essential considerations for any BI professional. You've been learning about database design and the role BI professionals play in creating and maintaining useful database systems. So far, you focus on the 5 factors of database performance: workload, throughput, resources, optimization, and contention. You also learned some strategies specifically for database optimization and what issues to check for if your team members start noticing a slowdown. You even explored how the 5 factors can affect actual databases, database optimization, and the importance of keeping databases up to speed. As a BI professional, developing processes that enable your team to pull insights themselves is a key part of the job. But systems and processes change over time. They stop working or need to be updated. That's one of the reasons why continuing to monitor database performance is so important. The database system should have lasting high performance levels. Coming up, you're going to discover more about optimizing systems and the tools you'll create as a BI professional. But first, you have another weekly challenge. As always, feel free to check back over any of the material and review the glossary to prepare yourself for success. Once you've completed your assessment, I'll meet you back here for more about optimizing ETL processes. Great job.